Awesome, awesome, awesome. Hopefully the audio is recording. I guess it is. I'm assuming it is. If it isn't, that's quite unfortunate because I'm not in the mood of checking. Fuck yeah, I'll check. I'll check. Let me pay some money. But
Awesome, awesome.
all right, cool. It is. So, yeah, I'm just reviewing some questions. If someone happens to stumble upon this, keep in mind this isn't really to teach anybody anything. I just need to essentially review some questions I did last week. I did a random number generator, and for some fucking reason, it decided to show my public IP. Why is a random fucking number generator on random.org showing me my own fucking IP back? Like, just generate the fucking random numbers. I am so confused why it decided, like, I don't know. Anyway, I put in some questions into a random number generator. It shuffled the numbers around, and basically it's going to be one out of any 16 questions I did in the last 8 days, essentially. All these questions are medium level, I think, except one of them. So they're pretty good questions, and they're highly rated and frequently asked. Well, not frequently, but they're like the fundamentals of graph questions in its entirety, essentially. So I think they're really good questions. I'm just going to do a re-review before I move on to a different category next week. I find it easier to just kind of do the questions in my own time, and then like kind of at the end of the week review them. But anyway, so the first question that wanted me to do was, on the top right is my iPad screen, which I have down here in the bottom. So 207. What is 207 again? 207. Course schedule. Cool. Course schedule. I'm just going to go ahead and delete this whole solution. Don't want to look at it. So the idea of course selection is, so before we start the question, because of course, these are things you're going to be whiteboarding, so you kind of need to draw it out and explain things. Is my stream even streaming? Is streaming? Yeah, it's cool. So let me hide this thing. It's kind of bothering me. Yeah, so essentially, course schedule. This is there are a number of courses. Some require prerequisites. So wait, there are a total of num courses that you have to take, labeled from 0 to num courses -1. Some courses may have prerequisites. For example, you take course 0, you have to first take course 1. Okay, so what's the category of this problem again? Shit. I swear I just did it as well. What's the category of this problem when one thing relies on another? It's not topological sort. It's the other one. That's like, hang on. Topological sort, union find, DVS, BVS. Oh, graph bipartite. So the idea is essentially that you should be able to split. So the idea here is that if I draw it out, actually, let's say you're given a list of numbers. I don't know. Let's say you're given like, let's say you're given like 5, 2, 3, 7. Actually, let's say they're even pairs. I mean, it doesn't really matter, to be honest. But let's just say, oops. I'd like to draw the notes app, but the problem is it doesn't have the fucking it thinks it's a MacBook on my iPad. When I use Sidecar to share the screen as a second display, I'm sure there is a way I can do it, but I don't want to spend like more than 5 minutes figuring this out. So the idea is, for a graph bipartite, the intuition is that you have a list of numbers, right? It could be pairs, it could be whatever. The point is that each iteration is an edge, right? Each iteration is an edge in a graph, and every element in the list of lists is a node. the idea is, can you split things off so that you can have two disjoint sets, two independent disjoint sets? So, for example, if we look at this 5, so we have two sets. Oh my god, that is horrendous. Oh, that's just disgusting to look at. Like, how do I... Yeah, I need to figure out this drawing thing for next time. I might not even draw it just because of how annoying this is. But the idea is you have two sets, right? And it's only two sets. That's the point of the word in bipartite. Its use is like, for example, let's say like a recommendation Netflix algorithm to I don't know, like user likes A, likes B, likes C movie, but and user X likes F, G, H movie. The idea is to like separate movies they don't like across all entities in the thing. I know I'm explaining that like shit, but the point is to just separate fucking things, right? That they're in a disjoint set. So we look at this, we see 5, we can add 5 to set U, we'll call this U, we'll call this V. With our set 5 here, you know, we can add we add 1 here. We'll just say that 1 and 2 can't be together. We add 2 here. We add, let's say, 3 here. We add like 7 here and 8 here. So this is one way. I mean, we have a disjoint set. It depends on the rule, obviously, of like when there is more than 1 inside of it. But the idea is to just have a disjoint independent 2 sets, right? So this is like kind of the idea of what's happening here. So in the example, they give 1, 0. Wait, is this a graph bipartite problem? Or is it a topological sort problem? Hang on. Fuck, yeah, it is topological sort. I knew, I was like, what am I even saying? It didn't even make any sense. Sorry, a lot of the graph questions kind of like get me mixed up. Yeah, I got that completely messed up. Because I drew it out and I was thinking, wait, that doesn't even make sense to what the question's asking. Sorry, this is a topological sort question. Goddamn. Yeah, okay. Topological sort question. Right. So the idea of topological sort is scheduling. It's the idea that you will essentially we have a graph that is a directed graph. It only works for directed graphs. We have to make sure there's no cycle in the graph, and that to do one thing you need to do another. So in this case, we have, for example, 1 and 0 are prerequisites. So they're nodes in a graph, right? Connected by an edge. So we have 1 and 0 in a graph, right? The idea is that to do 1, you need to do 0, right? So I guess you draw the arrow this way, doesn't really matter, I guess. But the idea is that to complete course 1, you need to do course 0 essentially, right? In the event it fails, there's a cycle, i.e., it would be that to do 0, you'd need to do 1. But obviously, as you can see, there's a problem here. There's kind of a deadlock. They both need each other to start. So I guess the scheduling never occurs. You know what I mean? You can never complete the program, or complete, in this case, the course. Really, it's kind of, you can think of it like threads in a CPU, or rather an OS system, trying to schedule threads and processes in a way that things aren't, I guess, cyclically relying on each other. So the first step would be to build a map of the, so you want to build a map of the prerequisites, essentially, right? So you want to build a map of the prerequisites. Kind of like, I guess, so let me draw it out. So you kind of want to do something like let's say course, and then the prerequisite. The idea is, for example, the first iteration. So there's two courses, right? So two nodes. So course 0 and course 1. At the start, you want to initialize to 0. I mean, initialize to empty, let's say, for example. Or I guess probably better to initialize to like an actual number. So let's say, let's initialize them to like I don't know, 1, yeah. Initialize them by default to 1. So the idea is that well, that's I'm actually not explaining this right at all, am I? Hang on. Fucking hell. I know the answer, right? It's just to explain it, I keep like skipping steps, and I think this is good practice to like when I get to having to do whiteboard interviews, but also kind of annoying because I'm left-handed and I have to draw over here, and this thing's in the way, and I'm using this shit drawing software. Oh my fucking days. Come on, you cunt. Holy shit, god damn. Alright. We initialize the fucking thing to 0, okay? And the idea is to populate the course with its prerequisite. You know, to complete 0, you don't need to do shit, right? To complete 1, you need to do 0, right? So you can start by initializing the thing to empty string, map of the emptiness. So for I in range of num courses, so we have an empty mapping, and the idea is to essentially okay, hang on. Topological sorting. The idea is to I have it in my head. I'm just trying to think of the implementation. So we have our mapping, and we're going through the thing. All right, we initialize to empty string. I mean empty array or list, and we essentially we want to DFS our way into this thing, right? Fuck, I'm getting shit confused. Hang on. I'm gonna quickly check my notes on topological sorting. I am getting a bit confused here. Topological sorting. I'm getting slightly confused here. Where are my notes? The fuck? Where did my notes go? Bruh, where the fuck are my notes? The fuck? The fuck? Where are my notes, bruh? So, okay. What did I say about this? So the idea is to topological sorting is, what did I write down? I said it's only possible to sort if it's a DAG, directed acyclic graph. Basically the in and out stuff. It's a linear order of nodes such that, or vertices such that for every directed edge U comes before V in the ordering. U becomes before V in the ordering. Okay. Topological sorting. Topological sorting is the idea of checking that what are we checking here? I mean, we have our, just like I drew here, we have we populate our thing, right? And then We have to visit each node. We have to visit the nodes. Visit the nodes to check what? What are we checking? To check that it's not already visited? Yeah. Yeah. Alright, okay. So yeah, we wanna populate the thing, so yeah, okay. So for course prerequisite in prerequisites, we want to append the course to our map to make just like the drawing we have, course.map, append the prerequisite. We have our DFS, so we can now check the check all of the things, because you can, because if you could imagine, we could have a case where we have like multiple prerequisites. So let's say, oh my days. So you could have a case where you could have multiple prerequisites. So like, let's just say in this list, because it's drawing software, it's garbage, I don't know what's going on, but let's say we have like 5 and 7 and 9, right? Or whatever. You want to like recursively check into that to make sure that they don't create cycles either. So we take our node. We want to actually, yes, we need to actually detect the cycle. We need to have a visit set. Yeah. So you have a node. If the if the course we're at is if course in visited, so if we've already seen the course, then we want to return false, because that means we'd be cycling. And if the course equals, let's say the course equals take our node. If our course, I should probably give this a better name. Course. So if I don't know, I think I like node better. If the node in the course, in this case, whatever the prerequisite is equal to, let's say, I think we could probably just make whatever up. We're gonna set it so like 2 or 1. Return false. Sorry, return true. We'll have it so that we'll indicate that basically we, inside of our table that I drew on the bottom left, we basically turn the values to 1 as we go through it recursively and backtrack, so we know we've visited and it's okay, it's not cycling or anything. So we have this case, and so we checked. These are some base cases. So we want to write some recursion. In this case, we want to for loop through our map for pre map. The reason we want to for loop through this pre map is because we need to recursively check all the values that could exist inside of a course's dependencies, prerequisites. It can have multiple, not just one value, but multiple values, right? So we want to recursively go into it, right? So this is just a case of saying if not DVS node, which in this case the node is the prerequisite, then return false. So basically it's just going to recursively go into the next ones and basically just keep doing this, checking this, and then checking this, right? Of course, by itself, this isn't really helpful because we need to obviously add stuff to visited to know. In fact, yeah, just I reminded myself we need to add stuff to visited. So every time you see a course or a node, to be honest, I'll just fucking call it a course. So yeah, every time we see a course, we want to add it into visited, of course. So, got some logic here. We want to return true if it hasn't returned false in any of the above statements. However, when we're backtracking back through the DVS, so when we DVS into it and then backtrack to the caller, so let's say, for example, in our diagram, if you look at it, we have 1 and I said 0, 5, 7s inside it. So if we were to recursively go to 7, we need to backtrack to 1, essentially, right? When we backtrack, that's when the value is actually being assigned and passed. So the idea is, we imagine we get to like a situation of 7 at the end of the prerequisites, and now we're at a base, and now we can look at the base cases. So what we can do is we can remove it from visited. First of all, in this for this course, we can remove it out of visited because we've seen its prerequisites, we've seen it's okay. So when we go backtrack to 1, we know 1's are going to be okay. So we can remove the course, and we can also assign the value some sort of anything. It could be literally anything, just to kind of check if it's valid or not. So I like just using 1 to indicate things that are valid, or that I guess using 0 would make more sense because error codes, right? So we make this 0. We so that's a DVS function. So now we just basically kind of do the same thing we just did there for pre in num courses. We want to just do the same check. So if not DFS pre, return false. Return false. Return false, and if it doesn't return false, then we can just return true, right? So this is gonna fail. I never get this around the first time. Of course, visited is not defined because I spelled visited wrong. Visit is not defined. Looks good to me. Yeah. So the idea is, I'll fix this for the next live stream, but I can't draw properly on this thing. But the idea is that we have courses that have prerequisites, right? And we have this visited, and the visited is only valid for the current course. And what is? Oh my days! Oh my fuck! Okay, fuck off. So the visited is only valid for the current course. So you know what? I'm not even gonna draw it. Fuck it. The idea is I'm submitting. Fuck this shit. Fuck this shit. All right, cool. These leetcode things are weird. Like, look at this. Wait, why did this run in 92 milliseconds? But this ran in 1.6 seconds. What the fuck? Wait a minute. What is going on here? Why is this solution so slow? Huh? What is going on here? Something is iffy. Did I do something wrong? What's going on here? What was my original solution? This looks exactly like the same shit. Oh, wait, is that because... Nah, that can't be the reason. That makes no sense. Wait, what? Is that because I use an empty thing last time? That can't be the reason. What? Nah, that's not the reason. Yo, why is this algorithm so slow? For pre in this... The fuck? Why was it 92 milliseconds the first time I solved this? For course in range. No courses. What the fuck? Bruh, I have no clue. I have no clue why this tell me 5%. Did they change the test today or something? Nah, it's weird. Okay, whatever. Okay. It's weird. Honestly, I'm just gonna disconnect my iPad. This just ain't working out. Like, I need to have it so I can use the notes app next time. Because drawing that ain't gonna help. I'll just draw it here for myself, but you guys won't be able to see it. So, all right. Yeah, I'll just draw it here for myself. Fuck it. Oh, that's right. Mouse is in the way. I need a bigger fucking apartment. I pay way too much rent to live in this tiny ass place. All right. Okay, so yeah, I don't know why it's so much slower now. The random generator is set to do 99. What's going on with my throat? It's so dry. What the fuck? The fuck's going on? 994. What is this? Rotten oranges? The fuck? Oh, this is a long ass looking solution. What the hell did I do here? Alright. Rotten oranges. This question had good frequency. Who's asking this question, actually? Who's asking this question? Amazon. Of course. Of course, niggas like Amazon be asking questions like these. Alright, what is this question again? You're given a grid. 0 is an empty cell. 1 is a fresh orange, and 2 is a rotten orange. So basically, it is the... So every single time it affects another orange, it rots them as well. But it has to be touching a rotten orange. Otherwise, it can't do it. It can't jump over. It can't go diagonally, and it can't go past the empty cells. So, all right, yeah. So this is just like, if you can imagine, it's just a rotten orange that is expanding. It's COVID-19 basically. So with every graph question, you always kind of start it out with getting the rows and the columns. That's just standard. It's length of grid and length of grid I for the columns. Standard stuff. So the idea is this would be a BFS, because as you can see the way it's expanding, I'm pretty sure you can solve this with a DFS too, but you could have a situation where the rotten, because you can have multiple rotten parts, right? Yeah, I think this is a pure BFS question. I don't think you can do this DFS. I'm sure you can, but I don't think it'd be good solution. Now, why is my head just drawing a blank right now? What the fuck? Oh damn! All right, hang on. We have our grid. We want to traverse to our grid, right? Yeah. So yeah, BVS solution. So, we want to say, we want to populate a queue of the rotten oranges initially, right? So, or a deck rather, which is a queue. But so for cell in rows, if grid. Wait. We want out all the rotten oranges. So for cell in rows, yeah, for, but we want the coordinates. That's the thing. So we want their coordinates, of course. So for row in rows, for col in columns. This mic is getting annoying. In columns, if grid I grid row column equals, and I wrote it orange, is 2. So if we just print this Q just so I can see it's actually doing what it has inside of it. What's the problem? Row and column for row in rows, for col in columns. If grid row col equals 2. Oh. Row. Invalid syntax. Why is this invalid syntax? For row in rows, for column in columns, if grid row equals 2. Why is it that? Row column. For row in rows, for column in columns, if grid row column equals 2. I don't understand. Why? What's the problem? Row for, yeah. What the fuck is the issue? Invalid syntax. What the heck's the problem? Bruh. I'm actually not seeing an issue here. For row in rows, row, for column in columns, if grid equals 2, row column. What's the problem? What's the fucking problem here? Row for row. All right, let me just Google list comprehensions real quick. List comprehensions. Oh yeah. Fuck no. Actually, fuck it. Fuck it. I'm just gonna do it the old classic way. Deck. Alright. For row in. Oh. Yeah. I didn't say range. That's the problem. Yeah, that was the issue. Actually, I just remembered we do need to keep track. We would need to keep track of the fresh oranges because it is asking us at the end, return the minimum of minutes that has no fresh orange. So we do want to have a check for that at the end. So I guess we want to have a count of the rotten and the fresh at the start. So fresh rotten equals 0, 0. So we'll actually just fuck it. Let's say for row in range rows, for col in range columns, if the thing on the grid is a 2, is a equals 2. If it's rotten, then add it to the rotten count. If it's fresh, then add it to the fresh count, just so that way we have a count of it. So if I print Q, what the fuck? It's empty. It should at least have one value inside of it. Huh. What the fuck? Yo, what is going on? Like, how? What am I doing wrong here? This Oh yes, shit. I'm not actually appending to the fucking queue. Yeah, of course. So we want to append the rotten as well. So not only do we want to count, no, sorry, we don't want to count the rotten. Why would we want to count the rotten? We just want the coordinates of the rotten. Yeah, that makes sense. So we want to just say q.append row column. So then now we should have 0, 0. Yeah, cool. All right, that makes sense. So okay, so we have a starting point, and now we can get along with the BFS. The input for the BFS would be the current node, right? The current node. So yeah, so we have a situation of of course we have our rotten queue already, or rather, is it the coordinates? The coordinates. No, yes, it's the coordinates. We want to feed in the coordinates of the node, because that's the coordinates we're expanding from, right? So we have our coordinates I and j. But of course, as you can see, the way they're expanding, it's level by level. So we do need to keep track of that. So we'll call it distance. We got our I, j, and distance. And yeah, I guess we just want to pop that out. Yeah, I guess we just want to pop that out because we have our thing. Yep. So q.pop left. Q.pop left. Then should I just feed in q? Well, we have ij in distance, and we have our q. We want to expand now in all 4 directions. So in this case, it'd be the directions from the rotten ij. So that's all 4 directions. So we want to go down. We want to go up. We want to go right. We want to go left. Let me do some checks. So you can say for new row, new column in directions. So basically it will expand out from IJD. I'm still iffy. Do I need to feed in IJD? No, yeah, of course, because we're popping it out. Yeah, okay. So the idea is we want to check that, first of all, that the new value we're moving to is on the x-axis is in the range of the rows, and we want to check that the value of the column y-axis is in the range of the columns. And what else do we want to check? We also want to check that the value on the grid is not an empty cell. So, and grid. So we want to make sure our new position as well doesn't equal 0, because that's an empty space. So now that we have that done, we want to then, of course, append the new position. We want to append the new valid position to the thing. Remember that we're expanding that from the rotten oranges. So as a result, we don't need to do checks to check if it's a fresh orange, because if we just don't check if it's a empty cell by default, since we're expanding out from the rotten, the only thing left is a fresh orange, right? So then we can say D+1. So the idea with the D+1 here is every single time we do a level of BFS, D will be that level. So if you can imagine in the graph over here, if you can, oh, I kind of missing my mouse. But if you can imagine, I'm looking at the graph over here. If you look at the second diagram, minute 2, it's saying that if you look at the right and the bottom, they're actually both at the same level, getting level 1 out of the rotten orange getting affected. So eventually, D basically increases after every level, right? So now that we have our thing, of course it's BFS, so we don't need to do any recursion or anything like that. Oh, the most important part about BFS is, of course, the while loop, which is probably what I was missing, wasn't it? This, yeah. This would go here, of course, because this is inside the for loop, right? I feel like I'm missing something. Okay, we have while Q for, yeah, in our directions from the rotten oranges. For new row, if the new row is valid and then something, then we append it. Of course, we have fresh oranges. We want to keep a count of fresh oranges each time. We can do that down at the bottom, but I'm slightly confused here. Slightly confused. Well, first of all, let me just get rid of that shit. Let's see. I feel like something's missing here. I don't know what it is though. I don't know. Whatever. It looks right to me. Like, and then yeah, finally, if we just go through the rows for row in range rows, for column in range columns. So interesting. Actually, hang on. For row and range rows, for range and columns. Well, every time we do this, yeah, we're decreasing the size, the fresh count, right? So what we should be checking is if the fresh value equals 0, then return true. Return true. This says if okay, so until no cell has a fresh orange, if this is impossible, return -1. So what are we trying to turn in? The minutes, right? The minutes. So if fresh equals 0, return what's this, D+1? Oh wait, hang on a minute. We have our fresh count. We have Q.append the new row, the new column, new row, new column. Append D+1 every time. I feel like something's missing. If we end up with 0 fresh oranges, so we've infected the whole thing. So we want to return D, of course. Right? Yes, we do. D equals 0? No, something. Output equals 0. Output equals D. Q depends 0. Of course. Something is off here. While Q pop out. Row columns. We refresh. We have a Q. A Q's populated with the fresh count. And our fresh numbers with the fresh count, and we have our output to be. Now that this output thing doesn't seem right to me. We want this to return D, because obviously then we can just call it at the bottom, right? So let's just say BFS, and I don't think this takes anything, does it? I mean, it's not recursively doing anything. So I guess it takes the grid, or rather the row and the column in this case. Well, yeah. Hang on, I'm gonna look at my BFS template. See what's going on here. Something feels off. Something feels weird. Something feels weird, but I don't know what it is. I don't know what it is. I don't know what it is. Time limit exceeded. What the fuck's happened? Hang on, I'm getting messages. What is this? What the fuck? Okay, hang on. Okay, I feel like the fact that I'm live streaming, it's distracting me. I'm gonna just try to pretend like none of this shit's here. Like, I'm just gonna put the mic away. I'm just gonna pretend like nothing's here, so I don't get distracted. Okay, so mic might be too far away, but fuck it. Test. All right, cool. Increase the. All right. All right. So basically, every time we go through the thing. No, of course we want to. Well, I guess you can just be clear and just say 1 rather than say it doesn't equal 0. Well, we actually do want to infect. Of course, we want to infect the new things. We want to affect the new coordinate, orange, of course, which is making it equal 2. And the D, which honestly I'll call this minutes, just so it doesn't confuse me. And I will just put this up here as well. Minutes equals. So yeah, every level we should add the minutes, right? Minutes plus equals 1. Minutes plus equals 1. Minutes plus equals 1. Isn't that just minutes? Well, interesting. If I actually print out the minutes, I should get 5 because there's n minus 1 level. There's n levels, but we want the n minus 1 first, I meant. Okay, something is off. Oh, shit, it's in the fucking for loop. Whoops, I didn't even... Oh, that's why it's timing out. The while loop is in the for loop. Still timing out. Why is that the case? Time limit exceeded. Oh, shit. I fucking said equals 2. Alright, cool. 5. Okay, so this is right. You know, because you return -1 essentially from that, because you know there's n levels, but the last one is just like you don't. We're 0 indexing here, so -1. So we have the amount of minutes it takes. We have the fresh orange. The fresh should be 0, so essentially return -1 if fresh doesn't equal 0, else. So if fresh, let's say if fresh equals 0, return minutes, else -1. No, wait, sorry. How does ternary things work in Python again? It's like if, else. So if fresh doesn't equal 0, then return -1, else return minutes, right? Oh wait, shit, maybe I'm doing that wrong. Hang on. Python ternary. How does this work again? A, if, condition, else B. If, else, A. Return minutes if fresh equals 0, else return -1, right? Okay, that's not right at all. Well, this should be -1 anyway. Wait, what's going on? Return -1 if fresh. Sorry, if fresh. Wait, what? Am I retarded? If true, else false. So what is in here? Let's return here, else false. Else false. So if fresh. Wait. You telling me fresh is not 0? How is fresh -1? What? Print fresh. 6, yeah. 6. How is this going down to -1? The fuck? Wait, what is going on here? Wait, do we always start with... Do we always like start with fresh? What, you telling me we always start with... Nah, that doesn't make any sense. What am I missing here? What's wrong with fresh? Every minute, so if you look at the diagram, we have 1, 2, 3, 4, 5, 6. We start off with 6 fresh items, right? We start off with 6 fresh items. That's correct, right? And we go down. It's going down 7 times. How's it doing that? Directions. Is this visited and multiplying twice? Is that the problem here? Should I add a visited situation? No, that wouldn't matter because we're doing these checks, so that's not. We don't need to say visited. Q.append. Should I do the fresh after? That just doesn't matter. It's in the same. It's the same conditional loop, same iteration. It's not going to change. How is this -1? Why is this running 7 times? What the fuck? I'm very confused. We start off with ij in the minutes. We pop left. We move our new direction and we check that the new direction is valid. Okay. And we also check that it is a fresh orange. Right? The only way it could move more is if for some reason it checks that. Oh wait, maybe I do need to say it doesn't equal 0. Doesn't equal 0 represent empty cell. No, because then that will get confused with 2 and 1. What's going on with fresh here, bro? Broski. I mean, yeah, we have 6 fresh shit at the start. I don't know what's going on. Hang on a minute. How did I do this last time? Am I doing something wrong? I'm confused. Oh, of course. If I'm saying fresh is here, that's right. We're missing it because we're already making the grid equal 2. So we need to get rid of it. The fresh indicate that it's fresh already. Yeah. Oh wait, nah. I just sounded so stupid. That did absolutely nothing. Fresh should not be -1. This doesn't make any sense. Okay, you know what? Okay, let me just print fresh for a second. I'm just gonna print fresh. How is it -1? What the fuck? Bruh. Oh my god. How is it -1? How is it -1? I actually do not get it. I don't get it. I don't get it. Because we start off, when we print it out, we see we have the right amount of fresh ones. I don't understand. I don't get it. What? I actually do not see what I'm doing wrong here. I genuinely do not see why this is printed -1. What the fuck is going on? Why is it printed -1? Fresh. We've printed fresh. 6, yes. 1, 2, 3, 4, 5, 6. There is 6 fresh things at the start. So what the fuck is the issue? Wait a fucking minute. What? Huh? Yeah, what's going on here? Python decrement. I'm not the only one seeing this, right? Wait, what's going on here? Minus equals 1. What the fuck? Wait a minute. I'm not the only one seeing what this weird shit that's happening here. Like, minus equals 1 is not working. But minus equals 1 is not working. Or is this... Oh my fucking days. I'm saying fresh equals minus 1. Oh my god. Oh my... Shit, okay, yeah. Fuck. I was like, what is going on? Alright. Return minus 1 if fresh doesn't equal 0, else return minutes minus 1. Yeah, I was just like, what is going on? 5%. What's going on? These questions. LeetCode is moving mad today. The fuck? LeetCode is moving mad today. Maybe it's probably on my end because I'm streaming, so maybe there's some kind of network latency happening. Probably. Yeah. Okay. I don't know what's going on there. All right. Next question was 1020. I did a lot of questions this weekend. God damn. Did a lot of questions. Did a lot of goddamn questions. How long has it been since I started this? It's been an hour. An hour to do 2 questions. I guess I did a lot of talking in it, which you have to do in the real thing. What's this number of enclaves? The frequency in this is mad low. Number of enclaves. Fuck is this? Let me get rid of this shit. Number of enclaves. What is this? Given a 2D array, each cell represents 0 and 1 land, and 1 represented land, 0 represents C. A move consists of walking down. Right. Okay, so we can move through the graph, horizontally, vertically. And we want to return the number of land squares in the grid for which we cannot walk off the boundary, off the grid in any number of rows. What? Return the number of land squares in the grid for which we cannot walk off the boundary. The fuck does that mean? There are 3 ones that are enclosed by zeros. Hang on, I'm gonna have to draw this one out real quick because I don't know what it. Alright, I can't visualize what it's talking. What it's talking about. Live stream. Alright, so we have 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, and 0, 0, 0. Okay, so we have some X and Y grid. Well, I and J. We have an I and J grid, and there are 3 ones that are enclosed by zeros. 3 ones that are enclosed by zeros. So you are telling me there are 3 ones enclosed by zeros, and 1 that isn't enclosed because it's on the boundary. We cannot walk off the boundary. So basically, okay, so we have to ignore the boundaries. Okay, I'll draw this in red. So we have to ignore the boundaries and ignore anything that connects it to the boundary. All right, this is definitely a DFS problem. This is definitely a DFS problem. So you know, typical rows, columns, length of grid for the rows, length of grid minus 0 for the columns. So we have, okay, all right, just gonna look at this diagram. Okay, so this is a DFS boundary and unvisited situation. So we need to count. Is this counting? How many ones? Or there are 3 ones that are enclosed. So we count the amount of ones that are enclosed by zeros. And using on the boundary. So we need to deal with the boundary first, right? Well, if we actually make the DFS function for that. So def DFS, we have our node. Node, what's the base case for this? Our node has to be in boundaries, right? So if the node is, this node has to be in boundaries, right? So what will fail the node essentially? If the node, sorry, yes, it's coordinates. I don't know why I keep saying node all the time. Coordinates. If I is greater than the rows would be, I guess the length of the rows. Yeah, so if it's greater than or equal to the length of the rows, or j is greater than the length of the columns, and if the value itself, is not a 1 in this case, so if it's a 0, return. If it's a 0, return, just return. Then we want to DVS our way to the top. Yeah, we do. So down. So rather up. Of course, we need to feed in the grid each time. Do we? I mean, it's a nested function. I don't think we do. Or do we? We probably would need to, because we are going to call it again, I think. So feeding the grid. So then we go down. DFS, the grid, ij plus 1, we go right. We go left. So, okay. And then we can return true, right? Something about this looks off. Something about this looks wrong. DVS up, down. But it's not doing anything. We need to, oh, yes. Once we find a valid value, we should actually give the value some sort of significance. So we should expand out on it. I always like using hashtags for DFS questions. So the idea is we find a valid element in here and we convert it to this, so then it allows us to expand out, right? So we want to deal with the boundaries first, which is of course the boundaries of, we want to deal with the boundaries first. So we want to ignore all the boundaries, right? So would that be ignoring the zeros or ignoring the ones? There are 3 ones that are enclosed and 1 that isn't enclosed because it's on the boundary. We want to expand from the ones. So this function is looking at the ones because it returns on the 0. So for row in range, rows, the top level is row 0 and column, no, all the rows, column 0. All of the on that side, which is rows -1, and columns -1 for the right side. And then we want to handle the top and the bottom for column in range columns DFS. So we want to go through all the columns. I'm just looking at my drawing here. I want to go through all the columns, but keep the row the same. And we want to go through all the columns, but only look at the last row, which is the theme -1. So columns, no, that doesn't seem right at all. Oh wait, shit, these are rows. Fuck. Rows. No, yeah, 0 column rows -1 and col. So basically, the one on the edge should be a hashtag thingamabob. So if I print the grid just to confirm, invalid syntax. Oh shit, fuck. What's the problem here? DVS. Oh shit. No, what? Oh, let me feed in the grid. I don't think I need to feed in the grid because I'm already in like the function, right? So yeah, I don't need to feed in this grid. Doesn't make any sense. That's the whole point of a nested function. Yeah, that should just work. Index out of range. Out of range. Oh shit. The fuck? Wait. Yeah, what am I doing here? The length of columns. Right, if I is greater than and critical 0, return. Otherwise. Maybe I do need to feed in the grid. The fuck? If I is greater than rows. If I is greater than rows. Oh no, shit. If it's either case, of course. If either case is the situation, then return. Then return, right? Yeah, so this outside edge, which is the first one there, should be hashtag. So now it's just about counting the ones in the middle with a so now that this is dealt with, now we just process the middle. So for row in range, what time is it? It's been an hour 15. I'll do one more question after this. For in rows, for call in range, columns. So it's really if the grid equals 1, then probably should count over here. Let's say number of enclaves equals 0. the number of enclaves plus equals 1. So then I should be able to just return the number of enclaves, right? Is not defined. Did I spell it wrong? Enclaves. Oh. Number of enclaves. Did I spell this wrong? Oh. Fuck. I typed too fast. So this should work. Oh. No, yes, no. Okay, something's wrong here. Alright. What's the problem? What's the issue? If grid equals 1. Oh shit, I'm not even calling the fucking DVS. Wait, shit. There's a problem here. Wait, I'm calling it DVS, but I call DVS. Wait, shit. Shit. If it's greater than or equal to rows. DVS grid row column number of enclaves, but that would only be 1, so that doesn't work. If the grid, this, even if this did work, it'd still be off. Maximum recursion depth exceeded in comparison. Interesting. Why is this happening? Return true. Am I missing something here? What question was this? Am I missing? The fuck? If it equals 1, number of enclaves plus equals 1. 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 So we do DFS to make it to the end. Okay. What am I doing wrong here? If this, do this. If this, return. If blah blah blah. If, I guess, oh yeah, you're right. Maybe else. Bruh, what the fuck? What am I doing wrong here? What did I do wrong in my function? Let me see what I did. Oh, I think I was doing my other way around. My original solution, I was considering the ones. So actually no, that should still work. What? Bruh, hang on a minute. That did work, because I ran it, the fucking edge things. It did work. Maybe if it's not equal to, if it's just greater than. If it's greater than. Hang on. If I is less than or equal to rows. If j is less than or equal to rows, and this is 1. The confusion is because, oh, I see. The problem would be because this is not matching. So in the event it's 0, it returns. I would need an else statement here. Or I could just make it easier on myself and say, I could just make it easier on myself and just say less than or equal to this. Less than or equal to this. Or grid equals a land, then do this, right? Then do that, so else return false or true. Return true. Bruh, what am I doing wrong here? The fuck? Let me check. Oh, that's, yeah, shit. Yeah. Fucking rookie mistake. Rookie mistake. I'm considering only the right and bottom. I'm not considering the left and the top, rear left and the top as the things. The first way I said it, even though that wasn't the way I did it, this should, doing it my way here should still work. The only problem was I wasn't checking the I wasn't checking if it was out of bounds the other way as well. J is less than or equal to 0. So this should work. Or not. Maximum recursion depth. It's less than or equal to. Alright, let's just do it the fucking other way. If this is greater than or equal to 0, if j is greater than or equal to 0, or I is, no shit, it has to be all of them. Isn't that it? If and that, and that, and it is that. Actually, no, yeah, then in that case, the way I did it originally will work. Right? So if it's less than, but no, then that's why the or is there. That should, yeah. Yo, I'm getting kind of confused here. Alright, wait. If we say it's this way, if I is greater than 0, and j is greater than 0, and I is less than or equal to the rows, and it is less than or equal to the columns, and the grid value is a land piece, then you want to consider it. Else you want to just return back nothing, basically. Yo, what am I doing wrong, bro? Oh, I forgot that. One? Actually, yes, I expected that to be 1. So interesting. Yes, I expected that to be 1. It's not counting them individually, is it? If it equals 1, which is a land piece, then DVS it. Well, we've DVS these parts, right? So then, do we even need to DVS this? We do. Wait a minute. Row. I think this is the problem, actually. Oh, shit. There we go. That's the fucking issue. We got row here instead of... Yeah, 1. So we don't... do we need to DVS this? I don't think so. Still out of bounds. What the fuck? Row 0. Row columns -1. 0 column. Rows -1 column. Alright, I'm gonna just look at what I did before, because I'm not sure why this is happening. I'm really not sure why this is happening. If I is greater than or equal to 0, j is greater than or equal to 0, fucking rookie mistake. Rookie mistake. Absolute rookie mistake. This still should not be 1 though. Number of enclaves. Wait, what? Yo, man, Mike J, what is going on here? This is so weird. That number should not be... That shouldn't increase by... Yeah, that should be 1, like I'm expecting it to be. If it equals 1, DV has to greater than the walls. Oh, wait a minute. That solution I had wasn't even right. How did that give me the right answer then? What the fuck? God damn. In my original solution, I had DFS here, but... Yeah, okay. You don't even need the DFS, because I was just thinking, that doesn't even make any sense. Because it will count the whole island we're collecting as 1. Yeah, I'm gonna have to copy and paste this again into my iPad, the correct solution, because I was slightly confused. And then I don't even know how it worked. I'm assuming it just failed. I mean, it just returned each time. Didn't even do the DFS here. So good, I spotted that. Good, I spotted that actually. I'm gonna paste the solve solution here. Alright, cool. Let me do one more. It's been an hour and 30 minutes. Let me do one more of these. Talking while doing this shit makes it feel like it's so much longer. Holy shit, man. Alright, the next was question 286. Question 286. Problem 286. Problem 286. 286 is walls and gates. This is a BVS problem, isn't it? It's kind of similar to the raw oranges. I'm not sure if I should do this one again. I kind of want something that's a bit different. 1, 2, 5, 4. Because this is just do another BFS like raw oranges. It's nothing really different. I don't really think it will benefit me anyway. What about 1, 2, 5? Number of closed islands. That's just like the DFS one. 733. Flood fill. That's also like DFS. That's not helpful. 200. Number of islands. Oh, goddamn. 947. Realistically, I'm trying to land on the. Oh no, fuck that question. Actually. Frequency. This is the joint and union question. I remember doing this one. This one's a real bitch. Yeah, fuck it. I'll give this one a shot. This question is a real bitch. I gave this one a dislike because it was kind of confusing. I felt like this one should have been hard. Even one of those leetcode veterans said it should be hard. But this was joined. Yeah, I remember I had to find a unit. This was the first thing I did. One of the first questions I did in the on my graph thing. The idea with finding union is to you have a set of edges and inside of it are nodes. You want to basically build a graph out of it, disjoint sets out of it, and then combine them, right? So I won't lie, I'm gonna need a help just giving a quick start on this one. I kind of forget the way it is. I know the intuition, it's just I slightly forget how I started this algorithm. Oh yeah, that's right. We did a whole class for the thing. Parents rank the ranks, the fucking path compression. Yeah, this question is kind of a bitch, but yeah, I remember I did this one. I like to make a class out of it, didn't I? Union find self and alright, so and self dot n equals self dot parents. Oops. Self dot parents. So this is, that's right, we start with a uninitialized adjacency list, which is of length n plus 1. This basically, it's a list that points to the parent of the node, the absolute parent of a node. And we are going to optimize the solution with union by rank. So rank parents. Yes, that looks good. Def find. This algorithm takes in x, and the idea is while. The idea here is that we want to find the absolute parent, right? So while x, so while the value in parent is greater than 0, then x equals recursively looking for the parent, because if it's greater than 0, you're saying that it's not a absolute parent. We just want to return x. For the union, which is a union of two sets, x and y, you want to join it in a way that's efficient. So ooh, hold on, I'm gonna have to look at this one. I kind of forget it. Yeah, we want to have the roots. Yeah. Oh yeah, the point is if the roots are equal, then it's a cycle. We're in the same set, right? If the roots are equal, we're in the same set. Well, the two nodes are pointing to the same parent, thus we have a cycle. So, okay. We want to deal with the rank as well. The one with the lesser rank gets assigned the bigger value, right? Let me think. What's this question again? A 2D plane we placed on some integer. Each coordinate may have a stone at once. A stone can be removed if it shares either the same row or the same column. Same row or the same column. We want to find the absolute roots of x. And the absolute root of y. Now that we have the absolute roots, we want to check that the here we're going to do some optimization union by rank. We want to check that if the parent, if the rank of the absolute root x is less than the rank of root y. We want to set that parent to be the one of the lesser rank. That way we're more efficiently joining it together and essentially not increasing the height as much. Essentially. Okay. Elif, and this is just the reverse. Elif it's greater than, then it's a situation of self.parents root y this way. So what this is doing is just saying that when we do join our disjoint sets, we join them in a way that, imagine x was longer and y was shorter. It makes more sense to join y to here rather than join the longer side to the shorter one, because then you're actually making a longer traversal. No, sorry. No, that's exactly what you want to do. You make the absolute root this point to this rather than this to this. Yeah. Makes sense. And then else, in the event that the ranks are the same, just, it doesn't really matter which one you join. Equals root y self dot parents. And you want to increase the rank, of course, because the rank only increases when the things joined together have the same rank. So rank of root x plus equals 1. Don't think we have to return anything here, do we? No, we just return true, right? We return true. We return true. In what case do we return false? Oh yeah, if there's a cycle, of course. Root x equals root y, then return false. Okay. Yeah, looks good to me. And then this should be our union find done. So now we just have our stones. A stone can be removed, so I guess we do want to count of the stones, right? Count of, oh, we know what's the count of, so count as n. So if we feed in our union find is the n equals the length of stones, and our union find is n. So we have a rank set, bird set count. So we want to just go through the row and column of the stones, right? So for row column in enumerate, where are we? In stones. In stones. Wait, for row column. Yeah, we want to build, the idea is if a stone shares the same row or same column. So if we build a set of the dictionary of what x and y coordinate belongs to what? Belongs to what? What row? What stone? So the idea is that row would be the stones of rows, the all the stones of a row. The row of all stones. So a row in a stone will be here. So that way, when we iterate again, if a stone has the same row or column, it won't do its thing. So if row not in, okay, guys, give us a rows calls. If row not in rows, if rows not in rows, then we can add it, right? So rows row equals the what does it actually equal? The row or the stone? It's the edges. The edges. We have our rows, we have our columns. That's the coordinates, right? Row column, if the row equals what? Oh yes, each edge is a stone, right? Isn't that right? Yeah, each edge is a stone. So we need the actual count of that, don't we? So stone is the count, while row and column is the actual stone. So each stone is actually the connection, right? So if row yeah, so the stone essentially, the stone equals the row. If column not in columns, then the columns of the stone equals column. And every time we can, well, actually each time we join, we do want to increase the count. That way we have a count of the stones. Or do we? Every time we union, no, we get rid of his stone, right? Every time we union. The standards end, so I don't think we need that. Something about this looks off. I just don't know what it is. Shouldn't it be the? Yeah, I'm pretty sure it's row column equals the stone, right? So really it's if row not in rows, if column not in columns, equals stone. If the column, if row is not in rows, then add the row of the stone and add the row of that stone. Okay, that makes sense. So then ultimately we just have to return the, what do we have to return? Every time we do that, in this case we don't want to return the count, right? Return the count. You have the count. Hang on. If that is the case, oh yeah. So I mean, if it's not in it, add it to the thing. Else we want to union the row and the stone together to make a connection in the graph. and we want to make a connection in the graph, a unique non-shared row column thing of stones in the thing. So now we should have a unique set of things. So every time we union, we actually do want to count, don't we? You have count plus 1. Yeah, that makes sense. We do want to count every time we do that. And after here, because it's going to be a cycle detection. So, so we return the ultimate count minus the n minus the count, right? Am I wrong? Am I right? What's this? Takes two positional arguments. Union. The union of union UF equals union find UF dot. Takes two positional, but three were given. Oh. Union find has no object parent. Has no object parent. Parents. Oh, god damn, did I say parents twice? Parents. Minus 5. Huh? N is the length of the stones. 1, 2, 3, 4, 5, 6. We can remove 5 of the stones because they share the same column and row. We now have a graph of stones that are just unique rows and columns. And if n is the count plus, it should be 0. Wait, what? Okay, this should be n. N as in 1, 2, 3, 4, 5, 6 stones. 6 stones minus the count. Minus the count. 6 stones minus the count of every time I join. Self.count. That doesn't sound right. Pretty sure this should be 0. Because we increase the count every time we join, right? Wait, what the fuck? Print n, print uf dot count. I don't know what's going on here. 6 and 5. Oh shit! We just have to return the count. Don't even need n, right? Okay, we do need n. What's going on here? What's the problem here? 1 expected 2. Wait, what? Honestly, I'm gonna just look at the solution while I was doing. Really just confusing myself here a bit. How did I deal with? Oh shit, of course. Why would I increase the count? The point is to remove the stones. We want to remove the stones. Yeah, that makes sense. Oh, it's still wrong. Okay, great. Great, self-counter. Okay, fuck, what's the problem? UF union. If row not in rows, columns. Hang on, this name is kind of confusing me. I'm just gonna say this. Okay, so we combine. If column, if col for stone for row column For it anyway stalls. If R is not in row, then okay, else UF dot union the stone and the row. If C is not in the column, then column C is stone, else union the stone. Then return 6 return. Are you sure it's not to return this? The fuck? What was this? Calls not defined. Oh. Still failing. What the fuck? Hang on. Print n print uf.count. Three two. uf.count counts how many times. Wait, so why is this failing? The fuck? Six and 1. Yeah, that's why I said n minus the count to give me 5. But it's failing here. 3 minus 2. Let me draw out the intuition on this and see why it's giving me problems. Just want to remind myself how to do this by hand because I don't really remember. So we have 0 1 1 0 1 1. This is 0 1 2. These are the nodes. We have 0 points to 1. 0 is connected to 1. 1 is connected to 0. 1 is connected to 1. What the fuck does that even mean? I kind of forget how this works. Hang on. I forget how to draw out the intuition for this thing again. Let me go back to my notes. So if we have an example of edges, we draw the edges out, what they point to. We have our node, which is our parent, and our rank. So we have our node list. From the absolute parent. -1, -1, -1. Oh, I do see the problem though. Rows should be row R, as in stone you're combining. The actual row you're combining. The column you're combining. Col's not defined. Col is not defined. Oh, column. Yeah. Okay, so the intuition for this was when given a theme. Yeah, 0 0 0. So I have this example where 0 1 2 3 1 2 0 4 4 3. So we draw our graph. And we say that the path compression y 1 minus 1 minus 1. We start at 0. This points to 1. We draw 1. We go to 2, points to 3. 1 points to 2. But that points to 3, so we put 3. 0. 0 points to 4. Wait. 0 points to 1. So we write 1. Right? 0 points to 1, because okay. Then 2 points to 3. 1 points to 2. So we update to 2. But we see that 2 already points to 3, so we put 3 down. 0 points to 4. 0 points to 4. Hang on. Area for 3 is the same, so return true. Is the same, so return not true, return false. Oops. I wanted to return false here. Zero points to 4. 4 points to 3. But doing that would mean that 0, then if you did that, that would be 3. That would then mean that 0 points to 0 would then point to 3 as well, because that would then point to 4. Right? If you added a 4 in, it would be problematic. 0 points to 4. Is that just because I didn't write it down? 0 points to 4. 0 points to 3 over here, but then it should point to 4. 4 points to 3. Oh yeah, that's because 1 was pointing to 3. Alright, which was the absolute root. Wasn't it? And then, yeah, that's why it didn't matter. Because the absolute root was. Then we said 4 points to 3. But if we did that, it would be a problem because then it would point here. If 4 pointed to 3 here, it'd be problematic because this would then be the absolute root. We'd create a cycle because 0 points on this. We have 0 point 4 points to 3. The absolute root equals the absolute root of 3 is itself. And the absolute root of 4, they would have the same absolute root. That would be a cycle. Then the rank increases. Rank not the same. Rank not changing since they're different. The idea here was that we were joining these and the thing. What question was 947? I'll still keep a list of this as a review for things to do later. But let's see what this is. Let's see what it is. Oh fuck! What the heck did I do? Unable to say read only. What did I just do? I made this read only somehow. Thanks for trying out Sublime. This is unregistered Get the fuck out of here. I don't pay for no license. Even though it is the best text editor, but like I don't need to pay for anything. I don't need those kind of features. 0 points to 2, which points to 3, which is the absolute root, so you can stop there. 0 then points to 4. The absolute root of 4 and 3 is the same, so return false. So we never get to that point. 1 points to 2, which points to 3, but if you look at it here, we have 1. Actually, I'm just going to quickly...
Hello guys, welcome. Since then, so initially will look, so point to 0, anything is fine since they are having same rank. Let us assume that I will take this 0 point to 1. So in this case, the parent of 0. Now let us include this edge 2, 3. Now in this case as well, for 2, 3, the rank is 0 for both of them and parent is -1, that is they both are absolute parents of itself. So they both are having different absolute parents, so union is possible. Now I will assume that I will make 2 point to 3. So this parent of 2 will now be 3